Hello, ladies and gentlemen. Welcome back to Math 31 Calculus, Chapter 4, Extreme Values, Lesson 4, Maximum Minimum Problems, Part 4. Now, we get to the classic lifeguard problem, which is you will see this a lot, lifeguard, or you're running a pipeline, or you're building a road. Anyway, the optimum lifeguard. The lifeguard can run at 6 feet per second and swim at 3 feet per second. What is the running distance? X equals AB. That minimizes the rescue time. That minimizes the rescue time. So here he is running X and swimming. Now, here's the lifeguard. And here's the victim. Victim? How do you spell victim? Person in trouble. There we go. So, lifeguard wants to run part of the way and swim part of the way. Now, if you do a little math, if you think about it, if he swims all the way, that's going to be a long distance at a slow speed, because swimming is 3 feet per second. So he's going to swim like 170 or 180 feet. If he runs all the way down here, now he runs at 6 feet per second. He runs all the way down here and then swims the minimum distance. That's still going to be longer. Somewhere in between, the sweet spot is where he minimizes his time. Now, I want to point out here, notice the way I've got this set up. X, he runs X feet. Then he starts swimming. Now, I also need to point out, we have a right angle triangle here. This is 150 minus X. This is 50. How far, what's the distance he swims? Well, this is BC, so A squared plus B squared equals C squared, or in this case, BD squared plus CT squared equals C squared, which is BC. D, BC. All right, squared. So BD is 150 minus X plus 50 squared equals BC squared. So BC squared is, okay, 150 squared, grab Mr. Calculator, 2250, 22,500 plus 300, no, minus 300x, sorry, plus x squared. Now 50 squared is 2500. So, BC, the distance, is the square root x squared minus 300x plus 2500. Like 25,000. Another zero. It's not a perfect square. So we say poopy and keep on going. Now, remember we're asking what's minimum time? What's the running distance that minimizes the rescue time? So we want to solve for time. Now you can do the homework later. Time is what? Now, velocity is displacement over time. So rearranging this equation, we get displacement over velocity. And this is the trick. You have him running on the shore a distance of x feet at 6 feet per second. And then you have him running or swimming a distance of square root of x squared minus 300x plus 25,000 divided by 3. Now, we have one equation with just x in it, and we need to find a critical point, maximum or minimum value. So what do? We take the derivative of time, which I don't know what that is, stress. Sorry. dt with respect to x. Notice it's time with respect to distance, not distance with respect to time. Let me see now. Derivative of 1/6x will be 1/6. The derivative of this mess, now that is the square root, so that's going to be 1/2 times x squared minus 300x plus 25,000, sorry, to the minus 1/2 times the derivative of what's inside 2x minus 300. So this is 1/6. Let me see, I have to rewrite this plus, let's see, 1/6, 2x minus 300. I don't need the 1. Over 6 times x squared minus 300x plus 2500 to the 1/2. Now, I'm going to simplify this mess. That's all even, so I can divide everything by 2. So I get x minus 150 over 3 times x squared minus 300x plus 25,000 to the 1/2. Now, critical value, and this equals 0, or does not exist. So let's look at the critical value if this equals 0. All right? So I'm going to subtract 1/6 from both sides, so this becomes x minus 150 over 3 times x squared minus 300x plus 2500. 1,000, God help me, the 1/2. It's minus 1/6. Cross multiply. Actually, I'm going to get lazy. 3, that becomes 2, divide both sides, or multiply both sides by 3. Now, cross multiply, that becomes 2x minus 300 equals minus the square root of x squared minus 300x plus 25,000. Now, I want to solve for x. What do? I square both sides. So this is 4x squared minus 1200x plus 300 times 300 is 90,000 equals x squared minus 300x plus 25,000. So I simplify. I subtract x squared from both sides. I'm down to 3x squared. Add 300 minus 900x plus 65,000 equals 0. All right, so what do? Plug that into my quadratic equation. X is minus b plus or minus the square root of b squared minus 4ac 2a minus 900 plus or minus the square root of minus 900 squared minus 4 times 3 times 65,000. So that, divided by 2 times 3. So that's 900. Now, that's 810,000 minus, and yeah, I admit I cheated. I grabbed Mr. Calculator. 30,000. by 6. That's 900 plus or minus 173. 6, which became 178.9, or 121. So, I'm going to stop there because that's a crap load of math, but anything particularly hard here? No, just horrible numbers and way too many places to make a dumb math boo-boo. All right, so let me see here. Note this distance is 150 feet, which means he can run a maximum of 150 feet. 178 is too far. So 121.3 feet is the most he can, is to maximize his, to minimize his time. That would be how far he'd run, 121 feet, and then swim the last bit. Now, I want to point out the critical value where the function doesn't exist. So I'm going back here, does not exist. So here, once again, the problem would be this is a square root. So is there a place where that would be negative? So x equals minus b plus or minus square root of b squared minus 4ac over 2a. Yeah, I'm just going to do the discriminant again. Minus 300 squared minus 4 times 1 times 5,000. And that is going to be negative because that's, sorry, 90,000 minus 100,000 minus 10,000. No solution. So there's no critical values of x where it doesn't exist. So the only critical value we have is 121.3 feet. All right? I'm going to stop there because that's way too much math. If you guys want to work on your homework, page 188, 120, and once again, you don't have to do every question. Do enough that you feel happy and confident you know how to do it. And remember, there's groups of them. So there'll be a bunch of this minimum time or the minimum pipe length, the minimum power line or whatever. Don't do everything. Do enough that you feel comfortable. Any questions, shoot me an email. Otherwise, good luck.